Hello, good morning to all the students here at the school, and to all the parents. We are going to start with the third shift. What you want?
Hello, we are Jare, Julen, and Yunan, and we are going to talk about the Bluetooth car. We use the M-Block program to control the Bluetooth car based on Arduino, which interprets commands received via the serial port to move it according to specific letters. Let's go through each part of the program step by step.
Now going to explain you the initialization. Start serial conversation at 9600 bits per second. This is when Arduino starts. This block initializes the pin when Arduino starts up. There are 4 digital pins, 8, 9, 10, and 11, and they are all set to low. These pins are lightly connected to the motor driver's module to control the motor's direction. Setting them to low means no current will flow through these pins until further commands are given.
Now I'm going to talk about main loop. The forever loop keeps the Arduino continuously checking for new commands. Inside of the main loop, we have check for serial input. Do serial port receive data? If data is received, it is stored in a variable called word or letter. The letter will be used to determine which action to take.
Our program can be adapted for different systems, like a traffic light control system with a barrier using serial communications. It reacts to commands to manage LEDs and a servo motor. For example, letter G is to go. The servo motor moves to open the barrier, and the green LED turns on, signaling to the car to pass. And the other LEDs that are red and yellow are off. Letter I. Prepare. All LEDs turn off briefly, and the yellow LED turns on to warn to the barrier will close on. And the letter R is to stop. The servo motors move to close the barrier, and the red LEDs turn on, signaling to the vehicle to stop. This program effectively demonstrates control over technical actions, servo and visual signals LEDs.
Now, to summary a little bit what we say, the letter R is to move, to turn the car right. The letter L is to turn the car left. The letter F moves the car forward. The letter B moves the car backwards, and the letter S is to stop the car. Each command is executed by setting specific digital pins to high or low, controlling the motor driver's output to move the car accordingly.
So now we are going to show in the screen their car. This is this group car. And maybe there are questions. Is there any question? Is there any question? So we are going to wait. Well, no, we are going to stop 1 minute, and we are coming back with the second group. Thank you.
So hello parents, we are right now back. So we are John, Markel, and Chen. So our specialty is about 3D printing. So I'm gonna start with chassis and the structure. So as you can see here, the chassis is made of 3D printed parts designed for easy assembly. And the body is a rectangular frame that holds all the pieces in place with two vertical beams that provide structural stability.
So we have the wheels attached to the chassis and to the DC motors, as you can see in the other camera. And the motors are DC motors that are attached to the main chassis.
The 3D printed parts are modular with screws and bolts to allow easy assembly and disassembly. The crossbars on top help stabilize the microcontroller and other electronic components, securing them to the frame.
Okay, is there any question? Do you have any question? Yeah, one moment. Okay, yes.
Did you design these 3D parts?
We didn't design these parts.
You only print then?
Yes.
In your opinion, what can we improve with regard to the 3D design for next year, for instance?
So we think that the pieces can be, I don't know, more smaller because I found it difficult to connect those cables because of the size of the pieces.
Okay, thank you. We are going to prepare for the next group and see you soon. Bye bye.
Hello, we are Araitz and Mikel, and our specialty are small motors that are here. Uh, Small cars that use DC motors work in a similar way to real cars. Both types of cars use electric motors as their primary propulsion system, powered by a battery that stores electrical energy. In both cases, direct current motors receive energy from the battery, which is converted into mechanical energy to move the car. This motor control system allows for smoother acceleration and efficient energy use, just like electric cars.
Additionally, just like full-sized electric cars, these small cars often include regenerative braking systems. When braking, the motor can act in reverse, generating electricity that recharges the battery. This technology, employed in most modern EVs, boosts energy efficiency by capturing kinetic energy that would otherwise be lost. And both cars also require motor controllers to manage speed and torque, ensuring stable that responsive driving. And these controllers are key to translating user input like thrower position into precise motor responses.
Altogether, small DC motor-powered cars serve as excellent models for understanding real electric cars, showcasing scalable EV technology from batteries to motor and regenerative braking.
Is there any question? There are two teachers here correcting the presentations. Maybe they have a question.
I suppose that the car has only one gear, as one speed, only one speed. No?
Yes. Yes.
Do you think it's possible to design a gearbox for the next year?
I don't know.
Yes, I think it can be an improvement for next year. Yes. Okay, thank you. We are going to have a break, and we are going to have the final group. Bye bye. Hello, we have the last group ready, but we have to explain that yesterday and today we have been dealing with some presentation with regard to the Bluetooth car. They have assembled some website, and all the website they have some tabs. The first one would be the home, the objective of their project, and in this case we have assembled or mount this car because we have a bigger car. This is a small car that each group has, but for the whole group we have a big car. And in this case, this group, Alex and Iker, they are going to show it. So when you want.
Iker. Well, hello, we are Iker
And Alex,
and this project has 4 parts. Technology, we mount a car. Craft, we assemble the bodywork, and digitalization, we program the website of the project. And economy, we find way to find resources for the car.
this is our car.
This is our class. This is our class. Yeah, saluda. And this is our car. The wheels, the motor. And see you, son. And next we continue.
We are going to have the next events calendar. First, 2 March in San Mamés. Second race is in May, Los Arcos in Navarra. And apart from those races, we will go to Zaldupe, Subizar and Alameda. We will show our amazing car. It takes maximum 35 km/h, and we expect to have female and male drives. Here you have a video of it.
Es la primera carrera del circuito de Vizcaya, la que se ha celebrado hoy en la explanada de San Mamés. Corren un total de 11 centros escolares y sus estudiantes llevan meses trabajando para crear un vehículo eficiente y sostenible.
Nos metimos en octubre.
Egurra jarri dugu, ondoren tela.
Materialak ikasolako materialak hartzea eta ez ordaintzea hartzeko materialak.
Ese es precisamente uno de los pilares de la carrera, fomentar la movilidad sostenible. Todos los vehículos son eléctricos.
Que se puede hacer un coche que participa en una carrera y encima lo podemos hacer limpio.
La innovación, el desarrollo, la tecnología, movilidad sostenible, bastantes conceptos que creemos importantes.
El trabajo en equipo, otro ingrediente indispensable.
Cambio bi vuelta edo hiru bakoitzak eta gero cambio dana kapu bat itzeko.
En esta carrera no gana el más rápido, sino el más eficiente y sostenible, el que sea capaz de correr más vueltas con una sola batería.
Buruarekin gidatzen.
Hori da garrantzitsuena, efizientea izatea.
En este primer circuito sumarán puntos, pero no está nada decidido. Correrán otras 4 carreras más en el territorio de Vizcaya. Los 3 mejores irán a la estatal.
¿Y qué vais a hacer hoy?
Pues
Ganar.
irabazi.
Espero baietz.
Beti positibo baina.
Okay, we have seen the video. I don't know if there is any question. Yes, one moment. Can you tell us, Araitz?
What do you think about cars being driving today without people in the car?
Yes, I imagine, that can be a possibility, but in our case, I think we have enough driving the car, and maybe it's more interesting driving the car inside the car. Thank you, Araitz. Okay.
How many battery has the car? And how many motors?
Okay, thank you to all the teachers and Eider and Gaiska, thank you very much, and all the students. You have done an amazing work. We will see each other the second term with the real car, and bye-bye. See you soon.